Hello, those who are attending online, whether voice is audible?
Yes, sir.
Screen is visible to you?
Yes, sir.
Okay. So see, today we are going to start our chapter number first from the what I can say subject, that is nothing but the electrical machine design. Okay, so in this chapter, as you know that this is the basic chapter related to our subject, that is nothing but the electrical machine design. Okay, so already we have discussed the syllabus related to this chapter, that is, and already you have written this in your notebook that which points is there. First of all, we have to study the principles of design, then design factor, then we have to go for the specification, and last point is nothing but the modern trends in the design of electrical machines. These points we have to study. Okay, everybody. Now everyone has the notebook. I'm hoping that everyone has the notebook with you. Okay. So see, as far as the principle of design is concerned, we will go with this one. That is nothing but the principles of the design. So in the principles of the design, basically two laws were there. These are considered as the principles of the electrical machine design. Which are the two laws? First is nothing but the Faraday's law of the electromagnetic induction, and second is nothing but the Biot-Savart law. Okay, how many of you know Faraday's law? Can anybody tell me Faraday's law? Those who are attending online as well as offline. It's very simple one. I think you have already studied it into the first year, and it is not like that those who have completed diploma, they have not studied. They have also studied. Okay, so can anybody tell me what is the Faraday's law? Or can anybody have the idea that which experiment Faraday has performed to get this, or to get into the conclusion of that particular Faraday's law? माहिती आहे का Faraday ने कुठले experiment perform केले होते? Okay, so we will see that, because that is very useful for us, because whatever that principle is there, that is generally utilized into the electrical machines. So which experiment Faraday has performed, that we will see now. Okay, so see here, Faraday taken the one, what I can say, you are seeing here into this particular, this is nothing but the one of the coil. Okay, and obviously whenever the coil word will be there, obviously it is the conductor. Okay, what he did, he has taken one coil, and to this particular coil, what he has connected, he has connected one galvanometer to this particular coil. Means one end of the coil is connected to the one point of this particular galvanometer, and other end is there, that is also connected to the another end of this particular galvanometer. And after that, he taken one of the magnet, okay, which is shown here. This is nothing but the magnet. And what he did, for first time, whatever this magnet is there, that magnet he moved towards this coil. Okay, now whenever he moved this magnet towards this coil, he observed whatever the deflection is there into this particular galvanometer. Whenever he moved this particular magnet to this, or whatever this magnet is there, when he moved this magnet towards this coil, he observed the deflection into this particular galvanometer. Okay, and after that, when he moved whatever this particular magnet away from this particular coil, then what he observed, exactly opposite deflection into this particular galvanometer. Means if he moved, if whatever the magnet is there, if he moved towards this coil, if the deflection he observed in left side, then what happens when he moved this particular magnet towards this right side or away from this particular coil, he observed deflection in exactly opposite direction, means towards the right side. Okay, means what conclusion he drawn is that due to this movement of this particular magnet, there is some effect onto this particular galvanometer. And as effect is related to this galvanometer, it is also concerned with this coil, which is connected to this particular galvanometer. Now, why this has been happened? Can anybody knows that why it has been happened? See, here they have shown you near to this particular, what can I say? Here, what is shown here? The magnetic field of that magnet. Okay, and whenever the magnetic field word come is there, or whenever magnetic field words arises into the picture, another word came there, that is nothing but the magnetic flux. Okay, whenever field word is there, then with that field word magnetic flux is also there. Means what happened, whenever he moved this coil towards this particular magnet, the flux linking with this coil is going to be changed. ओके, म्हणजे जर आपण ही स्टँड स्टील पोझिशन कन्सिडर केली कशाची, मॅग्नेटची, त्यांनी ज्या वेळेस हा मॅग्नेट टुवर्ड्स दिस कॉइल, व्हेन ही मूव्ड दिस मॅग्नेट टुवर्ड्स दिस कॉइल, व्हाट हॅपन, द मॅग्नेटिक फ्लक्स इज गोइंग टू बी चेंज. Then again if it returns back to original position and again he moved this particular magnet towards this right side, again magnetic flux will going to change. Magnetic flux change होणार आहे म्हणजेच काय होणार आहे, जेवढा ह्या काय मॅग्नेटिक लाईन्स आहेत, ह्या मॅग्नेटिक लाईन्स ऑफ फोर्स आहेत, जेवढा ह्याच्याशी लिंक होत होत्या कशाशी, कॉइलशी, कधी, व्हेनेवर दिस मॅग्नेट इज टुवर्ड्स दिस कॉइल, ऑब्विसली ज्यावेळेस मॅग्नेट अवे फ्रॉम दॅट कॉइल मूव्ह होणार आहे त्यावेळेस तेवढं लिंकिंग असणार आहे का, नॉट इज देअर, बिकॉज जेवढं मॅग्नेट तुमचं ह्या कॉइलच्या जवळ जाईल तेवढं काय होणार आहे, मोर फ्लक्स लिंकेज. अँड इफ दिस मॅग्नेट इज मुव्हिंग अवे फ्रॉम दिस पर्टिक्युलर कॉइल, somewhat less flux linkage than the original position. म्हणजे आधीपेक्षा ऑब्विसली फ्लक्स लिंकेज काय असणार आहे, कमी असणार. मीन्स व्हॉट ही ड्रॉज कन्क्लुजन दॅट whenever he moved this particular magnet towards this coil, flux linkage is going to change, and whenever he moved this particular magnet away from this particular coil, flux linkage is going to be changed. Now with the help of this experiment, he's drawn, or whatever the conclusion that he drawn, that is considered as the Faraday's laws of electromagnetic induction. And see, again I am telling you, whatever this Faraday's laws of electromagnetic induction is there, that is the basic of our electrical engineering. Our whole electrical engineering is based on this Faraday's laws of electromagnetic induction only. Have you got it? So it is moral responsibility, or I can say it is what I can say, जसं आपण देवाला कसं असं पूजा करतो तसं तुम्हाला ते फॅराडेज लॉज ऑफ इलेक्ट्रोमॅग्नेटिक इंडक्शन माहितच पाहिजे. You should know, because as you are, whenever you are going to face the interview, whenever they will ask you what is your stream, if you are saying no, my stream is electrical engineering, their first question is related to at least Ohm's law or Faraday's laws of electromagnetic induction. Have you got it? And see, many of the students are there, they went to final year but they didn't know still now what is the Faraday's laws of electromagnetic induction. Okay, now see, there is no necessity to behead that law. If you remember this experiment, then it is very easy for you to remember that law. Okay, no need to behead that law. तुला काय behead करायची गरज नाही. तुम्ही जर हा experiment, whatever the experiment which is performed by this Faraday, when you know that experiment, it is very simple to explain that Faraday's law. Okay, so what is the statement of this Faraday's law? See, Faraday's law, based on this particular experiment, Faraday has given this law. So this is the first law of the Faraday. So what it indicates, whenever there is a change in the magnetic flux linking with a coil or conductor, then what happens, EMF is going to induced in that particular coil or conductor. आता ह्यात तुम्ही लक्षात काय ठेवणार, ज्यावेळेस आपण ते एक्सपेरिमेंट करत होतो, व्हॉट यू ऑब्झर्व देयर इज अ चेंज इन दी मॅग्नेटिक फ्लक्स लिंकेज. दिस वर्ड इज व्हेरी इम्पॉर्टंट. अगेन आय एम टेलिंग, फक्त लॉ आहे म्हणून तो कसाही सांगितला तरी दॅट इज नॉट ऍक्सेप्टेबल. व्हॉट इज इम्पॉर्टंट देअर, until and unless change in magnetic flux is not there, EMF will not going to induce. जर आणि तरच तुमचं मॅग्नेटिक फ्लक्स चेंज झालं तर आणि तरच काय होणार आहे, EMF will get induced. So what is the statement of Faraday's first law? Whenever there is a change in the magnetic flux associated with the coil, you can consider coil or conductor, because if coil is there, obviously the whatever that material is that is obviously a conductor, conducting material. So whenever there is a change in magnetic flux linking with a coil, EMF is going to be induced. Okay, now see another, this is the statement, but whatever the EMF that is induced due to this particular, what I can say, experiment, or whatever the EMF induced there, that EMF is considered as induced EMF. त्या EMF ला आपण काय म्हणतोय, we can call it is nothing but the induced EMF. Okay, and again see, whatever the current which is produced due to this, that current is considered as induced current, and obviously that current will going to circulate through that coil only. ओके, त्या कॉइल मधूनच तो सर्क्युलेट होणार आहे, कारण दुसरं तिथून जाण्यासाठी कंडक्टरच नाहीये. नो अदर इक्विपमेंट इज देअर. What you have to remind here, whatever the induced EMF is, whatever the EMF is there, that is considered as the induced EMF, and whatever that current is there, that is considered as the induced current. Everybody, now whether it is possible for you to tell this particular law? सांगू शकते का, कांबळे सांगते का लॉ? काय फॅराडेज लॉ? What word is missing here? We don't have to keep that particular conductor or coil in magnetic field only. There should be a flux linkage. Now it is indirectly, means if we are putting it into the magnetic field, that means there is a flux linkage, but that should be replicated in your statement. Okay, read the statement. Here statement is given. Kamble, statement is given. That is only Faraday's law. Okay, whenever there is a change in magnetic flux linking with a coil, EMF will get induced in the coil. Okay, correct. Now don't confuse between Faraday's first law and Faraday's second law. Many of students don't know the what is Faraday's first law and what is Faraday's second law. Okay, see, whatever the Faraday's second law is there, that Faraday's second law taken the reference of this first law. त्या फर्स्ट लॉचा रेफरन्स फॅराडेच्या सेकंड लॉला आहे. तुम्हाला कुणी फॅराडेचा लॉ विचारलं, बऱ्याचशा स्टुडंटला ते आता ज्यावेळेस आपण सेकंड लॉ बघणार आहे, बऱ्याचशा लोकांना ते बाहेर आहे तो लॉ काय, तो रेट ऑफ चेंज झाल्यावर काय, ते बऱ्याचशा लोकांना बाहेर आहे. त्यामुळे डिरेक्टली तोच लॉ सांगतात, दॅट इज फॅराडेज लॉ. ओके, you have to clear into the mind is that whatever the Faraday's first law is there, depending upon that Faraday's first law, the second law has been stated by this Faraday. Have you got it? Now what is the Faraday's second law? See here, we will see that Faraday's second law. Now on which basis he has given the Faraday's second law, or why, how he has proposed? See, as you are seeing that what there is a change in the magnetic flux associated with the coil, or there is a change in magnetic flux linkage, and due to that what happens, EMF is get induced. So now into this particular Faraday's second law, what is the magnitude of that induced EMF, that is given into the Faraday's second law. ते जे काही EMF इंड्यूस झालेला आहे त्याची मॅग्निट्यूड काय आहे हे कशाने सांगितलेलं आहे, that is given by Faraday's second law. आले का लक्षात? That's why that induced EMF word is very important. Why? Because what is that value, on which parameter its value is depend, that is given by the Faraday's second law. कळलं का सगळ्यांना? What is the difference between Faraday's first law and Faraday's second law? Those who are attending online, whether they are getting what is the difference between Faraday's first law and second law? Whether they are getting or not?
Yes, sir.
See, until and unless the difference is not clear in your mind, then it is very difficult to tell that Faraday's first law and Faraday's second law. Now, what is Faraday's second law? See, it states that the magnitude of EMF induced in the coil, which is equal to the rate of change of flux that linkage with the coil. Okay. Now, what is the meaning of rate of change of flux? Can anybody define what is the meaning of that rate of change of flux? See, that rate of change of flux is given here in this particular mathematical equation. How many flux linkages there for how many time? That is nothing but the rate of change of flux linkage. Okay, have you got it? That word rate of change of flux linkage is very important. Whenever you are saying only flux linkage, that is not Faraday's second law. Okay, if you are skip this word, no, if you are skip this word, that is rate of, and if you are only seeing that the magnitude of induced EMF in the coil is equal to the change of flux linkage, then that is not considered as the Faraday's second law. What word is important here? The rate of change of flux linkage. Why? Because for how many times there is a flux linkage, depending upon that he proposed one equation. And which is that equation? See, he proposed this equation, that is nothing but the E is equal to N d phi by dt. Now, why he has considered this N? Can anybody tell why he considered this N? Yes, absolutely. See here, whenever you are going to consider this coil, no, this coil should have number of turns. Okay, ते जे काय लिंकेज होणार आहे ते कशा बरोबर असणार आहे, जेवढे काय तुमचे कॉइल्सचे किंवा कंडक्टरचे टर्न्स असणार आहे त्याच्यासोबतच काय असणार आहे, that will be flux linkage. That's why he has considered this term, which is nothing but the N into d phi by dt. What that N indicate? N indicates the number of turns to whatever that coil is there, to which that flux linkage is going to happen. And what that d phi by dt indicate? Rate of change of magnetic flux. Don't say flux. There are two terms: electric flux, magnetic flux. Okay, we are not going to consider with the electric flux, magnetic flux. Okay, see, there are some terminologies are there which is common in electrical as well as magnetic field, but they are having their own importance. If you are saying it only flux, no, it becomes generalized terminology. If you are saying only flux, it becomes the generalized terminology. What we are going to concern here? Magnetic flux. Have you got it? So see, only simple word matters a lot. Have you got it? Simple words matters a lot. तुम्ही ज्यावेळेस स्टेटमेंट बऱ्याचशा वेळा आपल्याला काय वाटतं, आपण जे स्टेटमेंट लिहिलेलं एक्झाम मध्ये ते करेक्ट आहे. अजूनही मी आता जरी सांगितलं किती जणांना ओहम्स लॉ लिहा, मी गॅरंटी देऊन सांगतो 98% स्टुडंट विल नॉट राईट दी ओहम्स लॉ करेक्टली. It's my guarantee. Why? Because the final statement or final that important what I can say statement is there, 2-3 words that are very important. What you say as per as the Ohm's law, तुम्ही काय म्हणणार आहे? Whenever whatever that current is directly proportional to the voltage between what that 2 point is. But what is important here? That physical condition remains constant. If you are not going to write that word, no, physical condition will not remain constant, that Ohm's law is not applicable anywhere. Okay, so these small words matters a lot. It tells your smartness. Okay, अजूनही कुणाला सांगितलं, if now I will tell, no, tell the Ohm's law, what they are going to tell, what V is equal to I. Whether this is the Ohm's law or this is the equation of Ohm's law, this is the equation of Ohm's law. Okay, now see, now this is the generalized part I will tell you. Whenever I attended the interview, no, related to this, what I can say, one of the when I was in the final year at that time, what attended the interview, no, what happens is that they asked me the, what I can say, that Ohm's law in Marathi. Now that I have studied it in, I think, 5th or 6th standard. That time I didn't know that Ohm's law in Marathi. Okay, when I was in final year, how many of you know in Marathi? Nobody knows that law in now Marathi. Okay, whether anybody knows that? No one knows. Okay, but why, on which basis they have asked me that is that, see, in that particular resume I have written my mother tongue is Marathi. Okay, as they are saying that your mother tongue is Marathi, no, you should know the Ohm's law in Marathi also. And it doesn't mean that no, you are also facing the Ohm's law in Marathi like that. Such a type of question words are there. Have you got it? So that's what I am to say, that word is having very, very importance there. So what is that? What is important here? That whatever the change in the magnitude of induced EMF into this particular coil, that is equal to the rate of change of flux linkage with that coil. And see, whatever that rate of change of flux linkage is there, that is given by the equation, that is nothing but the E is equal to N into d phi by dt. What that E indicates? EMF. Okay, that N indicates nothing but the number of turns, and that d phi by dt indicates the rate of change of flux, magnetic flux. Got it, everyone? So this is our first principle that is involved into the design, which is nothing but the Faraday's laws of electromagnetic induction. Now based on this, we require the another principle, okay, which is also we can consider as the very, very important part into this principles of design. Now which is that principle, or which is that law? See here, that law is nothing but the Biot-Savart law. Now what this law given? See, they have given there. What this law explains us? This law gives us the value of force produced. Now when force will going to produce, they have given on account of interaction between magnetic field and current carrying conductor. Okay, so if we are having the conductor, and obviously whenever that conductor is going to carry the current, and whenever that conductor is going to be placed into the magnetic field, so at that time whatever the force develop, or whatever the amount or whatever the value of that force, that is given by the Biot-Savart law. What Biot-Savart law given us? What it given? What it given us? Whatever the force, value of the force, but which value of the force? Whenever any one of the current carrying conductor is there, and whenever that current carrying conductor we are going to place into the magnetic field, at that time whatever the force developed, that magnitude is given by the Biot-Savart law. Okay, आता ज्यावेळेस तुम्ही whenever you are into this second year, at that time also you have studied the construction of DC machines, whatever it may be, into the generator or DC motor, whatever it may be. That time also, whenever you are writing the what I can say principle of working of that particular DC machines, that time also there is a reference of this Faraday's law and the Biot-Savart law. But there itself we are not concentrated that much, that it is the linking of Faraday's law, or it is the linking of Biot-Savart law. Okay, so what is that force? What is the magnitude of that force? See, what is the magnitude of force? That is given by F is equal to BIL sine of theta. Now whatever that term is there, that term having their own meaning. Now see, they have given what is the B, what is the value of capital B? That is nothing but the flux density, which is measured in कशात measure करतो आपण flux density? What is that? Weber per meter square. Another unit of flux density, what is that? Correct, it is the Tesla. Okay, see, the unit of each and every quantity is also important for us. Without that unit, that quantity doesn't having any meaning. Okay, you have studied in 11th physics, one chapter is there at the time of starting. I don't know what is the name of that chapter. measurement. Okay, why you have studied that chapter? Because whatever the quantity is there, that having meaning when they are having the units. Okay, so what is the unit of that flux density? That is Weber per meter square. See, from this particular unit, no, you also remind the formula for this particular flux density. Okay, many of the times we were into the confusion that what is the formula for flux density. So if unit is Weber per meter square, what in which terms we are measuring the Weber आपण कशासाठी वापरतोय? Flux. And for meter square it is nothing but the area. So flux divided by area, it concerns the flux density. Okay, so if you know the unit also, you know the formula also. Weber per meter square. Now then, what is this L indicates? This is nothing but the length of the conductor. Now suppose, see, if this is nothing but the what, you can say magnetic field is there, and if this is the conductor is there, which is placed in this particular magnetic field. Okay, so whatever the length of this particular conductor is there, that is measured in L. Upper length, but it is always measured in which unit? That is nothing but the meter. Okay, whatever the length of conductor is there, that we are considering it into the meter. Next, I. What is that I? Current carried by the conductor. But which conductor? The conductor which is placed in that magnetic field. It is hidden here. Okay. म्हणजे आता इथं असं तुम्ही त्याचं हिडन अजेंडा आहे की व्हॉट एव्हर द कंडक्टर इज देअर दॅट इज प्लेस्ड इन मॅग्नेटिक फील्ड इटसेल्फ. So what is that I? I is nothing but the current carried by that conductor which is placed into the magnetic field, which is measured in which unit? Which is measured in the ampere. Obviously current is measured in the ampere. And now the very last point is there, that is nothing but this angle theta. What that angle theta is there? See, the angle between the direction of the current and the direction of magnetic field. Now see here, if the direction of magnetic field is in this direction, okay, I have shown arrow there, and if whatever this conductor is there, that conductor is going to carry the current in this direction. Now whatever this angle is there, okay, you can consider this angle. This angle is nothing but the theta. But only that angle theta we don't have to take. What we have to go for? It's sine. Sine ratio we have to take. See here, they have given it as nothing but the sine theta. Means until and unless angle is known to us, म्हणजे जोपर्यंत आपण अँगल माहित नाही तोपर्यंत आपण साइन काय करू शकत नाही. It is not possible for us to take that sine ratio. Okay, so what that angle is? That theta angle denotes the whatever the angle which is between kasha matla angle hai? It is given here, the direction of current and the direction of magnetic field. Everyone got it? It is not like that every time the direction is in this way. Okay, but generally if we are considering the north pole here and south pole here, then magnetic field direction will be from north to south. That's why I have just shown by this particular arrow. It is shown here. Okay, and only we don't have to take the theta. What we have to do? We have to go for the sine of theta. So what is the magnitude of the force? BIL sine theta. Obviously, in which unit we are going to measure the force? Newton. We are measuring the value of the force in the Newton. Okay, means these two are the very important laws, or we can say principles of the design that which we are using in this particular electrical machine design. Which are that principles? First is nothing but the Faraday's laws of electromagnetic induction, and second is nothing but the Biot-Savart law, which gives us the what? The force. But which is force is there? Whatever the current carrying conductor, and whenever it is placed into that magnetic field, whatever the amount of force is there, that is given by the Biot-Savart law. Okay, so those who are attending online, whether they have got this? Those who are attending online, whether you got this point?
Yes, sir.
Remaining people, whether you are there or just you have said here for only presentee.
Yes, sir.
Rule number 24, Aishwarya, whether you got this?
Yes, sir.
Can you tell me the Faraday's first law, Aishwarya? Whether it is possible for you to tell me the Faraday's first law? Aishwarya. See, whenever you are saying yes, no, it itself meaning that you got something. It is not difficult. That much Faraday's law is not difficult. Don't make it difficult there. We have to study a lot of difficult from this. Who is going to tell me this law?
Whenever changing magnetic flux linked with the conductor and EMF induced in that conductor.
See, again I am telling, the words carries a very much important meaning. Whatever you are saying, in hurry, you are saying that law. That word is very important, magnetic flux. Without that flux, it is not possible to, there is no meaning of that Faraday's law. Okay, only that we are going for playing cricket, but there is no bat and ball. What is the use of that cricket? What we have to do, only we have to run on that particular ground. Whether that is considered as cricket? No, it is considered as athletics. Only if we ran on that particular ground. So at least ball bat should be there for playing cricket. We can manage stumps anywhere, but at least ball bat should be there. Okay, so whenever you are going to saying the law, no, that should be a perfect. Because see, the definition and laws, they should be replicated as it is. Whatever their explanation is there, that you can write by your own way. It doesn't matter. म्हणजे तुम्हाला काय जे समजलं हे तुम्ही तुमच्या वर्ड मध्ये लिहू शकता. But law you can do not tell by your own words. Then it becomes your own law. Okay. Then तुम्ही जर तुमच्या, if suppose what I can say, if person is there, he is writing his own law. If he is having surname Patil, it become Patil's law. Okay, so don't do like this. See, that's what I am saying. The definition and laws, only these two are very important. Because if you are changing the Kirchhoff's law, then what is the use of that Kirchhoff's? Then तो जर law आपण change करून लिहिला, then whatever the experiment he has performed, that is waste, no? Means what I can say, we are not accepting their concept, we are denying it. You have put it very wrong law. Okay, so it having the very important meaning. So these are the two important laws that we are going to concern it into this electrical machine design. If into the ISC, the question will be raised like this: write short note on principles of design. Don't only write, just mention there that laws. Which law? Faraday's law. Mention that experiment also, so that you will get good marks. Whenever that question will be arises, that explain or write short note on the principles of design used into the electrical machine design. At least whenever into the oral examination, they will ask you at least what is expected, कुठले law आहेत हे तर माहित पाहिजे. Statement, that is the next case. But कुठले laws आहेत हे तर आपल्याला माहित पाहिजे. Which two laws are there? येते का सगळ्याला येईल का फॅराडेज लॉ सांगतात? मोरे येते का फॅराडेज लॉ सांगतात? Why? Or you need to contact Faraday? At least try. At least try. I taught, no. Now itself I taught Faraday's law. Whether I should repeat once again? Now for your sake of convenience only, I am repeating once again. But now it is moral responsibility of you, is you have to tell the law after the repeating this. Okay. So what is that Faraday's law here? On behalf of only him, we are going to concern that law now. On behalf of him only. What is that law? Here, Faraday's first law. What is that? Whenever there is a change in the magnetic flux linking with the coil or conductor, the EMF will get induced. ज्या वेळेस मराठीत सांगतो तर ज्या वेळेस मॅग्नेटिक फ्लक्स लिंकेज कुणाचं जे की कॉईल आहे त्या मॅग्नेटिक फील्ड मध्ये त्याचं चेंज होईल त्यावेळेस काय प्रोड्यूस होणार आहे EMF will going to produce. In Marathi I have told now. Got it everyone? Okay. And what that second law indicates? What that second law? Again you are doing same mistake. What that indicate? That law doesn't start for rate of change of flux. The another word is very important. The magnitude of induced EMF. That is equal to the rate of change of magnetic flux linking with the coil. More whether you got this now? Now tomorrow we will start lecture with Faraday's law only, and that is going to be start with you only. Now you have to what I can say, study a lot whenever now you went to hostel. Faraday's law should be there. We will start it with you only. On might be tomorrow I am not having lecture. On Monday we will start you with you only. But make sure that on Monday you should not absent. That should not be there. On Monday you should be there. And if possible, sit first bench so that I can get you in within a short time. Here it is presenting. Otherwise I will get forgot what I have asked you. See, whenever why I am this saying it is important, because these are the basic things that everybody should know. At least Faraday's law, Ohm's law, Kirchhoff's law, that everybody should know, because these are the basics of our electrical engineering. If we don't know this, then it becomes very difficult. Okay, you can also ask the BE student, those who attended the Bharat Forge interview, ask them what they have asked into the interview. Ask them what they have asked. They have not asked any what I can say application oriented thing. They have just asked the basic things. If I will introduce the resistance here, then what will be the value of current? Then what is the Kirchhoff's law? If you are saying that what I can say incoming current is equal to outgoing current, how you are decided? Such things they are asked into the Bharat Forge interview. Okay. So see, no one will going to ask you application oriented, because they knows that whenever you will enter into the company, that time your power will going to develop. But at least basic आपल्याला माहित पाहिजे. म्हणजे त्यांनी असं एक्सपेक्टेशन करू नये की तुम्हाला काय नाही माहित तरी आम्ही तुम्हाला कंपनीत घेतोय. It is not expected. You should know some basics. Whenever you are attending any software company interview, at least you should know who invented that C language. That at least that is expected from you people. Okay. So this is the what I can say. Now the next point is that we will going to study it into the next lecture. But what is that point? Design factors. Okay. Now see here. Whenever we are going to concern the design of any machine, that design should be appropriate, or that should be desirable. Desirable in the sense that it should be as per our requirement. Okay, म्हणजे design machine केली आणि it will not give you the best performance, then what is the use of that? म्हणजे तुम्ही मोबाईल घेतलाय, if you have purchased the mobile but it is not up to the mark, then what you are feeling? You are feeling bad that yeah, I have not purchased that mobile, it gets some hang and all these things. Okay, so what, whenever you are going to design any machine, that should be have some appropriate what I can say desirable output should be there. So in order to get the desirable output, which design factors we have to consider? ज्यावेळेस आपल्याला एखाद्या मशीनचा आपल्याला जसं पाहिजे तसं आउटपुट पाहिजे असेल, तर डिझाईनचे कोणते फॅक्टर आपण कन्सिडर करायचे? Which factors we need to consider whenever we are going to design for any machine, or whenever we want the desirable output, that should be included in this point. That is nothing but the design factor. Which factor we need to consider whenever we want the good output or desirable output? Desirable output आणि good output मध्ये भरपूर फरक आहे. Good output म्हणजे काय आणि desirable in the sense as we want, जसं आपल्याला पाहिजे तसं, that is desirable output. And good in the sense okay, the machine will going to run whatever it may be the output. Okay, desirable output and good output. So these points, which are the points there now as far as the design factor is concerned? The first point is magnetic circuit, then second is nothing but the electric circuit, third is nothing but the insulation. Fourth is nothing but the cooling system, or you can say another word is ventilation. And fifth point is nothing but the machine parts. So these are the 5 parameters, or you can say 5 points are there that you have to consider whenever you are going to design any machine. Okay, and in second chapter also we are having special design on the cooling system of the transformer. You have also written the into the syllabus, you have written the cooling system, design of transformer with and without cooling tubes. Okay, so that cooling part is also very important. Whatever we have studied today, whether you got everyone, कळले का सगळ्यांना? हे तर बेसिक जमायलाच पाहिजे. Yet not now we have not started the machine design. These are the basic first chapter, that is the introduction. In that, whatever the basics related to our chapter, that which we are going to cover. कळले का सगळ्यांना? आता येईल का सगळ्यांना? Faraday's law सांगता, whether it is possible for you. See, it is not like that. I am continuously talking and you are continuously listening. I know that who is attending and who is not attending, although I am having specs. Okay. I know that who is listening, who is not listening. So your concentration 100% should be on that blackboard, not their blackboard, that screen. It is also black, but black screen. Okay. A white screen. You can take your favorite color, white. See, whenever I am teaching this, no, it is not like theoretical subject. Whatever the theoretical subject you are studying, no, studying here, not listening, going to home and writing by your own words. It is not like that. Our each problem is very important, because each problem is having link with another problem. Okay, if you miss the calculation, how we are going to solve the next problem? That is expected. So there should be 101% concentration on the blackboard only. And whatever the student, those who are attending online, it is not like that for you only. Just log in Zoom through your mobile. You have to listen my good voice. Although my voice is not good, but you have to listen. Okay. So just a minute. I want to see who is present there. Rutuja, whether my voice is audible to you? Rutuja. Put the roll number in front of your name so that I can identify what is your roll number.